Intelligent Transportation Systems Podcast. Hi everybody, we're back on track, bringing you the ITSPodcast, our periodical show on intelligent transportation science and engineering. Welcome to episode 18 for October 2014. I'm Javier Sanchez Medina from the Intelligent Transportation Systems Society. We have a super exciting episode ready for your ears, for our special listeners and followers. Do you know that Toyota has a huge facility in Ann Arbor, Michigan, where they have an awful lot of amazing projects on human factors, active safety, passive safety and biomechanics, and post-crash projects? Well, we have interviewed Chuck Gulash, director of the Toyota Collaborative Safety Research Center. He kindly explained a lot of innovative concepts. For example, do you know what is radical collaboration? Well, you will get surprised when you hear what is behind that challenging task. We also have a delightful transportation history mini section by Mehran Shirazi about the history of a very simple yet important passive safety system, the 3-point seat belt. For the pessimistics about human nature, that was an example of some car makers that could have made millions with that invention but chose to open their patent instead. Please listen also the news mini section. We have a very important call for nominations to the IEEE Transportation Technologies Award. Are you ready? Fasten your seatbelt and get ready to enjoy.
This is the news mini section for October 2014. This is a call for nominations to the IEEE Transportation Technologies Award. The nominations deadline is January 31. The nominee can be an individual, a team, or multiple candidates, up to 3. The selection will be done based on the impact on the profession or society, sustained contributions in topics like monitoring, control, power, navigation, and communications as applied in transportation systems, leadership in accomplishing worthwhile goals, and others. Please check out this podcast website at ITSPodcast.com for further information. One final announcement. The 2014 IEEE International Conference on Vehicular Electronics and Safety has extended its submissions deadline to October 15. So, if you are interested in sending a paper, you still have 2 weeks.
Transportation in History by Mehran Shirazi, PhD candidate at Simon Fraser University, Canada. Car safety over the 20th century. Most of us know that Princess Diana and James Dean died in car accidents. What many of us don't know is the fact that every 30 seconds someone dies somewhere in the world due to a car crash. Only in the United States, the annual cost of accidents is about $300 billion, which is about 2% of the GDP of the country. These figures would have been much higher without vehicle safety systems. In the last 35 years, safety systems have reduced the number of fatalities by about 50%. The very first safety systems emerged at the beginning of the 20th century. 4-wheel hydraulic brakes in the 20s, safety glass, padded dashboard and seat belts in the 30s, and safety cage and disc brakes in the 40s were all among the early attempts of car manufacturers to increase the safety of the cars. As another example, 2 engineers in Sheffield attached a safety scoop to the bumper of a car. When the driver was about to hit a pedestrian, the scoop could be opened. This car catcher could save the life of the jaywalkers. Nowadays, many advanced driving assistance systems such as lane departure systems, automatic braking, adaptive cruise control, and adaptive headlamps are available. However, the most important safety device ever invented is the 3-point seat belt. Before 1959, simple 2-point waist restraint usually caused more harm than good in the accidents. Volvo engineer Niels Bohlin made this revolutionary invention which could make a lot of money for Volvo from the patents. However, Volvo opened up the patent because they believed the invention is a significant life-saving tool and it should be free, not a profit-making tool. The application of 3-point seatbelts started in a Volvo PV544 in the town of Kristianstad, Sweden. Today, all car companies use this valuable invention, which has saved more than 1 million lives so far. Now you can easily fasten the seatbelts, sit tight, and look forward to the development of more car safety systems in future. But meanwhile, if you ever have a crash and survive because of your seatbelt, you have Niels Bohlin to thank for. You should also thank Volvo for putting human lives ahead of the profits of the company.
Okay, let's get to the primary content of this episode, the interview to Chuck Gulash. It's incredible to have someone right from the front, from a top car maker research and development center. Relax and enjoy it. Today we are with Chuck Gulash, Director of Toyota Collaborative Safety Research Center at Ann Arbor, Michigan. Chuck Gulash is Senior Executive Engineer at Toyota Technical Center, the North American R&D division of Toyota Motor Corporation. Gulash joined TTC in 1996 as General Manager of Vehicle Evaluation at the Arizona Proving Ground and has held a series of leadership roles in vehicle evaluation, performance development, materials development, and advanced research. He became Vice President of Vehicle Evaluation in 1999, Vice President of Vehicle Evaluation and Engineering in 2002, and Vice President of Research and Materials Engineering in 2006, before assuming his current position in 2011. Let me welcome now our guest. Hello, Mr. Gulash. How are you? Can you please introduce yourself to our listeners?
Hi, Javier. Yes, I'm looking forward to this opportunity for the discussion, and I'm talking to you from our technical center in Ann Arbor, Michigan.
Mm-hmm. Can you please describe the North America Toyota Technical Center? For example, how many researchers and engineers work there?
Yes, we have over 1,100 engineers and team members at Toyota Technical Center. It's the largest R&D facility for Toyota outside of Japan, and it was founded in 1977, and we're part of our North American Engineering and Manufacturing Organization. And we do vehicle and powertrain design and planning. We have 5 North American chief engineers here. We conduct vehicle and materials evaluation, prototype build, and also do advanced research for sustainable mobility.
That's huge. And could you tell us what distinguishes the Collaborative Safety Research Center from the other parts of TTC?
Yes, CSRC is different from within TTC, Toyota Technical Center, but it has a lot of other differences also for the industry. Like other automotive manufacturers, most of Toyota's R&D is done behind closed doors, but CSRC's objective is to conduct the research externally and in an open environment so it can be shared. And we're not aware of anyone else doing something exactly the same anywhere globally. Mm-hmm.
Well, Chuck Gulash was so kind to deliver a very interesting keynote at the recent Intelligent Transportation Systems Society's Intelligent Vehicle Symposium last June in Dearborn, Michigan. The title of his plenary was Radical Collaboration Contributing to Intelligent Vehicle Research. I think this is such a challenging and intriguing title. Can you please explain what do you mean by radical collaboration?
Yes, Javier. I borrowed the word radical from the title of a book that I read called Radical Openness, and Don Tapsco was the author. He's related to the University of Toronto and has given some TED Talks, and this is actually a book that's published by TED organization. And one of the concepts that he talks about is that collaborative innovation is really an opportunity to optimize. In the age that we're living in now of networked intelligence, where knowledge, skills, and ingenuity are distributed more than any other time in history, you can't do it all in one location or in one organization. And so, we're looking at the same kind of concepts that Don talks about in his book.
Mm-hmm. But I guess the answer is no. But isn't this collaboration contradictory with Toyota being a profit company? What is the trick? How do you sell to your bosses in Japan this is a good and profitable idea?
The nice thing about Toyota is I didn't have to sell the CSRC concept. When we were developing this, we did it together within North America as well as Japan. And going back to some of the concepts in Don Tapsco's book, sharing is no longer considered altruistic. It's really about increasing your access to talent as well as good ideas. And so, at Toyota, we believe when good ideas are shared, great things happen, and it was just a natural evolution for us.
Uh-huh. Chuck, your talk was plenty of innovative and challenging concepts and ideas. For example, an integrated approach for advancing science through what you call cross-pollination. I think that is a beautiful metaphor. Can you please explain about that?
Yes, the CSRC portfolio is both broad as well as deep. And we're aimed at preventing crashes and protecting against injuries that may occur if a crash happens. And we've got a very diverse, multidisciplinary team of research collaborators, many types of engineers, as well as computer and machine vision scientists, software and big data experts, and we've got a number of our collaborative partners that are coming from the medical community. For example, pediatric trauma physicians, emergency room physicians, neurologists, and even psychologists. The listeners to your podcast, if they want to dig deeper, there is something that's becoming known as convergent science, and MIT has some good reference material that they can search for.
Mm-hmm. That's cool. Another intriguing statement was that you mentioned about collaboration by redefining the Hadron matrix. What is that matrix, and why does it need redefinition?
Back in the 1960s, a person by the name of Dr. William Haddon, and he was an epidemiologist, came up with the concept. And, being one that studied trauma, he would, he had a concept that said, and any kind of trauma, but then he started to focus it on automobiles, is that an event happens where an injury takes place. There's activities prior to that event happening that may be able to be utilized to prevent it from happening in the first place, or once that has happened, then there might be activities that could be done to mitigate the results. And there's different domains that could be used for these activities or interventions. And so he basically had a matrix, thinking along the top, pre-crash, crash, and post-crash, and then along the side of vehicles, people, and infrastructure. And that's held true since the mid-1960s, but there's so much more technological advances that are happening in the automobile industry now, I think it's worthwhile to rethink, are there any modifications to that matrix? And I don't have those answers right now.
I see. Well, you also mentioned that your center has 30 research projects on radical collaboration. That's a lot. Can I ask you how much has Toyota invested in this? I think our listeners will possibly better visualize this way. How important is the research you conduct in Ann Arbor for your company?
Back in 2011, when we announced the formation of Collaborative Safety Research Center, we mentioned that we're committing $50 million US dollars over a 5-year period, and the vast majority of that amount is going to our collaborative partners. And we're coordinating that research from our R&D headquarters here in Ann Arbor, but it's being conducted across the U.S., into Canada right now, and eventually into Mexico. And so right now we've got 17 universities and research hospitals that are involved.
You also explained that these 30 research centers are categorized in 4 different beings: human factors, active safety, passive safety and biomechanics, and post-crash projects. Can you please tell us what is the most exciting happening in each one of these?
Yeah, I'd love to do that, Javier. There's a great story to talk about each individual project, but that would take a long time. So, I'll just give you some samples. And if the listeners want to see some more, they can look at our website, toyota.com/CSRC. But in the human factors area, we're doing a number of projects related to driver distraction, building a cognitive model, looking at voice demands, looking at mental models and trust between a driver and an automated vehicle. And we're also looking at projects for the effect of in-vehicle technology on older adults and our attentional functions. In the active safety area, we're doing test standard development for pre-collision systems, PCS systems, related to vehicle, pedestrian, bicycles, and as well as animals. In the passive safety and biomechanics area, we're working with our research partner to build human body finite element models of a 10-year-old child and a 70-year-old female. We're also working with a partner to look at older occupant postures, body shapes, and seatbelt fits. And in the post-crash bin, we're working with partners to develop algorithms to assist in post-crash emergency response triage.
Talking about those models you mentioned, I think it's very interesting that you are sharing them. Do you think that a static human model is good enough, considering that actual pedestrians usually, they move when they are near a road, and they possibly project a more complex dynamic model? So do you think it's safe to train that active safety systems with just those static models, or is this just for a first stage of development? What do you think?
The human body models that I mentioned that we're developing, and these are finite element models with 2 million nodes in them, are really used for post-crash activities, for understanding injury modes after a crash, things that might occur in real-world conditions. These models have not only the skeletal structure, but they have internal organs, including the brain. And so we're looking at injury mechanisms in those models. For the active safety systems, the activities that CSRC is working with our research partners to develop, those are more physical representations of a vehicle or of a pedestrian that can be seen by vehicle cameras or radar.
Mm-hmm. I think that the main sensor used for the detection of pedestrians and animals is radar, right? Why radar? Why not vision, which is a cheaper sensor and maybe can be equally nicely integrated in modern cars, and in the opinion of some colleagues, provides a richer information of the world around the vehicle. So, why radar?
Yeah, the sensors that are used in pre-collision systems vary from vehicle manufacturer to vehicle manufacturer and even car to car, but they include both radar as well as camera systems, mono cameras as well as stereos, and so. At CSRC, we're not doing the actual vehicle development, but we noticed that in the test device early on for vehicle test sensing, the industry was using balloon cars. Because when you hit them, they didn't damage the vehicles under development. But balloon cars appear pretty well, much as a real vehicle for cameras. But for radar systems, they're not so realistic because their surfaces are changing in the wind, and so that's one of the reasons why CSRC, developed some projects to improve those test models.
Well, very well. We now need to make a short break. We'll be back in a few seconds, so please stay tuned. Hello again. Do you want to get a warning to your email with every new podcast? It's easy. Visit ITSP.cicei.com. There you can subscribe by entering your email address both at the right side widget or the bottom right follow tag. Once introduced, your email you will get a confirmation message where you should click in the activation link it contains. However, if you're more like the kind of smart apps fan, you can search for this show at your preferred podcasting application. Search for the keywords intelligent transportation and you will find us. Remember, intelligent transportation. Thanks for listening ITS Podcast. Let's get back to our interview. Here we are again with our guest today, Chuck Gulash, from Toyota Technical Center for North America. Chuck, in your talk you mentioned that concept, naturalistic data. We are hearing many naturalistic things in our area lately. Could you please talk to our listeners about that? What is that concept about and what does it have to do with intelligent vehicles research?
Yes. Naturalistic driving studies are being done around the world right now, and they've really emerged within the last 10 years. One of the very first ones was done at Virginia Tech Transportation Institute, known as the 100 Car Study. But recently in the U.S., the largest data collection project was completed, and over 3,000 vehicles and 5 million trips and 50 million miles of travel and were recorded. And naturalistic driving studies are really just that. It's people driving in their own vehicles, in their own commute or errand running activities, but they're done with vehicles, their own vehicles that have sensors added to them. In the case of the recent one that was completed here in the U.S., which is called SHARP2, SHRP2, and funded by the U.S. government, there were a number of video cameras inside the vehicle as well as outside, and other sensors like radar and accelerometers. And this is giving researchers really around the world a look into what people are actually doing while they're driving. You may think that people act differently when they know that there's all these sensors, because they're all volunteers. They're all doing this on their own choice. but after about a half hour, when you see some of the things that people are doing in their vehicles, they've clearly forgotten that they're being recorded. But at CSRC, maybe half of our projects have some component of an on-road or an naturalistic data study activity. Either we're gathering some data or we're helping to build tools to help researchers evaluate this data. So there's more than 2 petabytes of video data, for example. In the Sharp 2, so it's not going to be able to be done manually.
Mm-hmm. That's great. Chuck, we are witnessing lots of new cars, including fancy tactile devices. But you said about using voice recognition instead. Do you expect this to become a tendency, considering that with voice recognition we will not need to stop staring at the road to command them?
Yeah. So a big issue for driving anywhere is distraction, and it's often characterized as having 3 components: visual, manual, and cognitive, where your eyes might go off the road, you take your hands off the steering wheel, or you take your mind off of driving. And particularly in the cognitive area, there's much to be learned. But to enable people to interact with their navigation system, for example, voice commands are part of today's vehicles, and we're studying it at CSRC to help understand what the cognitive load is. And of the study that we completed at MIT last fall, we learned together that cognitive demand is really lower than expected with the voice systems, but that visual demand became higher than expected. So it really, even though it's voice, it's multimodal. And part of that is because as humans we're social animals, and a number of people would actually look to the center of the car and talk to their car when they were giving it a voice command. So we need to take that into consideration as we develop the future products.
Mm-hmm. Well, let me end this interview with this one. Chuck, many car makers are announcing plans to put autonomous or automated vehicles in the market as soon as in 2020. What are the plans of Toyota in that sense? Is Toyota sticking to the development of more and more sophisticated advanced driving assistance and safety systems?
Well, at Toyota, our immediate goal isn't necessarily a car that drives itself, but it's one that has intelligence. It's always attentive. Technology that helps make driving safer. Kind of like a teammate for the actual driver. And each company has different approaches toward automated vehicles, but the eventual introduction of automated vehicles will be a very complex, and is a very complex topic, beyond just the vehicle portion, the sensors, the control, the human factor technologies. The complexity includes regulations, legal issues, insurance, even as well as individual and social acceptance. And so at Toyota, we're participating in projects really around the world to help understand all of these things. And we're moving forward with that research, and we'll see where it leads.
Mm-hmm. That's interesting. Well, Chuck, thank you very much indeed. I'm positive that our listeners will be more than happy to enjoy this interview. Thanks.
Thank you, Javier. Great talking to you.
Goodbye.
Bye.
Very well, that was it. Please feedback us with your comments on this interesting interview. We are really waiting to see your reactions. Thank you. Stay tuned for next episode. We are already preparing a special episode about the almost opening IEEE Intelligent Transportation Systems Conference in Qingdao, China. This podcast is sponsored by the IEEE Intelligent Transportation Systems Society. Website designed and managed by the Innovation Center for the Information Society at the University of Las Palmas de Gran Canaria in Spain. Soundtrack developed by Rubicon. Language advisory by Manuel Arbelo and Professor Son Williams from Clemson University, South Carolina. We'll be back soon bringing you again the cutting edge of science at the Intelligent Transportation Systems podcast. Thanks for listening and drive safe.